Okay, I thought I would go through number 41. They want us to find the open intervals on which the function is increasing or decreasing. Apply the first derivative test to identify all relative extrema, and then use a graphing calculator to determine our results. Okay, the big idea here is, if you remember, if I use the first derivative test, I can take out of each little interval that I have, I can pick a point in the interval, take the derivative of it, which is equivalent to finding the slope of it, and if it's a positive number, the function's increasing, and if it's a negative number, the function's decreasing. The problem is kind of weird here. They ask us to find the open intervals on which the function is increasing or decreasing in A, and then B, they say identify all the relative extrema. Really, we almost have to do B before we do A, because if I'm going to make intervals, I got to know where my critical points are, or I can't make my intervals. So, in order to find my critical points, my relative extrema, what I have to do, if you remember, is take the first derivative and set it equal to 0. So let's take the first derivative of this function. The derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. So there's my first derivative. Now, if I want to find my relative extrema, and again, the reason I care about them is I've got to break my function into the pieces where it's increasing or decreasing. I got to know where all those points are to make my little intervals. So I got to set this equal to 0. This took a lot of work on the board in class today, so I'm sure it's going to take up several pages of the iPad. If I add sine x to each side, I'm just going to move the sine x to the other side, I get sine x is cosine x. Now from trig, do you remember what values of x had the sine and the cosine values be the same? Well, what we could do is think about, if you remember, 45, 45, 90 triangles. At 45-degree angles, your sine and cosine were the same thing. Remember, sine is opposite over hypotenuse, so let's say I pick this angle. Opposite, let's see, if you remember, for 45, 45, 90 triangles, we labeled them x, x, x squared root of 2. So the sine was the opposite side, which was x, over the hypotenuse was x squared root of 2, and that reduces to 1 over square root of 2. And the cosine value of 45 degrees was also, it's the adjacent side, which is an x, over the hypotenuse x squared root of 2. And so it equals the same thing. So I remember that my reference angle where sine and cosine have the same value is actually 45 degrees. And 45 degrees is pi over 4. So now if you look in the instructions, they ask us to do this for the interval 0 to 2 pi. So I don't have to do it everywhere. If I think about this, from 0 to 2 pi, we've got, let's see, pi halves, and then you go to pi, and then you go to 3 halves pi, and then you go to 2 pi. Now, I'm going to have a 45-degree angle on the interval 0 to 2 pi. If you remember, the period of sine and cosine is both of them is 2 pi. I go through a whole rotation of the function in 2 pi. So that it happens at 45 degrees. And then it happens again if I look at if I draw it like this, I kind of drew the function out on an xy coordinate. But if I'm looking at the unit circle, 45 degrees would be one angle where they're the same if I go from 0 to 2 pi. And the other angle where they would be the same would be a 45-degree angle here. They would have the same cosine value. Now, I got to be careful about that, because let me think a minute. Remember, the signs are going to mess me up here. All students take calculus. So in the first quadrant, the sine and cosine have the same sign. And then over here in the third quadrant, the sine and cosine have the same sign. They're actually both negative here. They're both positive in quadrant 1, but they're both negative over here. So what I want, one of my critical points is going to be at pi fourths, but the other place would be a 45-degree reference angle right here where they would both be negative. And you think about that, that would be pi plus pi fourths more, which would be 5 pi over 4. So these are my critical points right here. Now I'm going to have to go to another slide in order to kind of do the table here. I want you to remember, though, when I took my derivative, it was cosine x minus sine x. Derivative That's supposed to be a prime, but again, the iPad doesn't pick it up, was cosine x minus sine x. Okay, and what I've just figured out is that I have this is equal to 0. Remember, it's where does this equal 0 is where my maximum and my minimum values, my critical points occur. And then at my endpoints, and then any place the function has an undefined derivative. This function doesn't have any undefined derivatives, and the endpoints are not the critical points here, but I'll use the endpoints when I make my intervals. So I came up with pi fourths and 5 pi over 4. Those are my critical points. Okay, so I'm going to make my table now, and in my table I'm going to write my intervals. Remember, I'm going from 0 to 2 pi overall. That was given to me in the problem in the instructions. So I'm going to go from 0 up to pi fourths. It's going to be one interval because that's one critical point. Then I got to go from pi fourths to 5 fourths. There's another critical point. And then I got to go from 5 fourths up to the end 2 pi. So this is a 5 over 4. You can't read it, but it's 5 over 4. Now, I'm using radians here. I could just as well use degrees, and so let me do that just because I think it'll make us be able to find these values. This is like from 0 to 45 degrees. This is from 45 degrees to 5 pi over 4. Pi over 4. Let's see, 4 over 4 pi would be 180 plus 45 would be 225 degrees. If I'm rotating, if I'm graphing on that, unit circle type thing. And then 5 over 4 would be 225 degrees to 2 pi, which is 360 degrees. These are my intervals. So what I'm going to do is make a table out of these intervals. Okay. Let me use some black here just to kind of help break this blue up. Here's my 3 intervals. This work over here to the side was when I was trying to figure out stuff. Okay, these are my critical points here that I got with setting my first derivative equal to 0. All right, what I need to do is pick a value that's in there. I'm going to call that value C, and I need to know, I want to pick a C value. Then what I'm going to do is find the derivative at C. I'll basically plug it into cosine x minus sine x. Then I'm going to see what is the sign. Is it positive or negative? If it's positive, it's increasing. So if it's positive, I'm going to say it's increasing. And if it's negative, I'm going to say it's decreasing. Now, the hardest part of this is just going to be plugging in the numbers, I think. All right, so I want to find numbers that are easy to evaluate. And if you remember, we had, when we studied trig, one of the things that made things easier to evaluate is if we had some nice values. Like, for instance, let's think about 30, 60, 90 triangles. Maybe I can use this to my advantage. Let me go ahead and label those. Across from the 30, you call it x. Across from the 60, you call it x squared root of 3. And across from the 90-degree angle, we call that 2x. So what I'm going to do in this first interval, I'm going to pick 30 degrees, which if I wrote it in radian form, 30 degrees would be the same thing as pi over 6, because that's 180 divided by 6. So whichever form you want to use is fine. Now, what I need to do is I need to find, remember the derivative is cosine x minus sine x. Okay, so for 30 degrees, what's the cosine value? It's adjacent over hypotenuse, so it would be x over 2x. That would be a half. But then I have to subtract sine x. Sine x is opposite. Oh, wait a second. That was the cosine value there. Oh, that's what I want. Okay. The sine value is opposite over hypotenuse. I just messed this up. Let's do this again. The cosine value of 30 would be adjacent, so SOHCAHTOA, adjacent over hypotenuse, so that would be square root of 3 over 2. I got the sine and cosine backwards. Cosine is square root of 3 over 2 minus sine. The sine was a half. I just got those backwards. Now, square root of 3 is a little bit over 1, so it's a little bit over 1 over 2 minus 1 over 2. That's going to be a positive value, okay? So that number is positive. So therefore, if it's positive, then the function is increasing. This is what it wants me to do. It's increasing from 0 to pi over 4. Okay, now, let's go to the next interval. Between 45 degrees and 225 degrees, What's a good easy value to evaluate this function, because it's got cosine x minus sine x that I got to do. Well, how about pi halves, 90 degrees? Pi halves, which would be the same thing as 90 degrees, whichever one you want to use. I'm going to come down here and I'm going to draw my unit circle just to remind you of how we could do that quickly. 90 degrees is that first right angle there, correct? And that point is 0, 1. If you remember from trig, the x value is your cosine value. So it's cosine x, cosine 90 degrees would be 0, minus sine x, the sine of the angle is its y value, so it would be 0 minus 1 is negative 1. Well, that number is negative. If it's negative, the first derivative test says the function is decreasing on this interval. So we've seen the function go up, and it came to a critical point. Now it's going to go down. Okay, so we can tell a little bit what's going on here. We could look at our graphing calculator when we're done and verify that we've got the right stuff, but we're trying to do this without a calculator first. Now, between 225 and 360, you know what a great thing to do there would be? I could do some kind of, I could do like a reference angle there, but also 270 is in there. That's 3/2 pi. Why don't we do that? We could use our unit circle and make our lives so much easier. I'll kind of work in purple down here. 3/2 pi is this 270 degrees, and if you think about this, this is the point 0, negative 1. So the cosine value would be 0 minus the sine value is the y value there. It's negative 1. 0 minus minus 1 is 1. Oh, that's a positive number. That means the function is increasing there. So when you write your answer, you would say from 0 to pi over 4, it's increasing. From pi over 4 to 5 pi over 4, it's decreasing. And from, it should be 5/4 pi. From 5/4 pi to 2 pi, the function would be increasing. So we see it's doing something like this. Now, if you look at your calculator and you plug that in, you can kind of see that's what's going on, is that you have increasing, decreasing, increasing. Remember, we don't care about the whole function from infinity to infinity. We just care about this part from 0 to 2 pi because that's what they told us they wanted in the problem. So you can check that on your calculator. You can even see where your critical points are by finding your maxes and minimums. Remember, you could put the function on the y equal, then you could go to second trace min and second trace max to find your critical points and see if we got them right. You just have to remember that you're going to have to think about, well, what is that equivalent to in radians? And so you could either do some kind of formula to transform over, or you could divide pi over 4 out and see that you got a maximum there. You could divide these numbers out and see that it's matching the decimal values you get.